What are the reasons for drug resistance? One is maybe you're not taking your antiviral drugs on time. Here is an interesting point here. This is good. This is what I wanted. Okay, here we are seeing someone who is taking antiviral drugs at the proper time. You see, he has started at 7 a.m. The next dose is at 7 a.m. So the drug concentration is neither too high nor too low, which is good. That's what we want. Now, what happens if someone skips a dose at 7 a.m.? He starts here. You can see the crossover point is below sub-therapeutic. It is less than what is required. It's sub-therapeutic. And there, the crossing over point is down there. So this is not going to help. You already started to develop resistance. Skipping a single dose in a month, maybe it can be allowed, but again, it's not good. And then this region is what we call as a Goldilocks zone, which means it is neither high nor too low, perfect. Now here you have already started to develop resistance. And then here, doubling the dose. You skip the dose, but the next time you take more of the same drug, what can happen? Drug toxicity will evolve. Okay, so again, it's not good for your body, it's excessive. Okay. And this is the sad part, which is the transmitted resistance. Transmitted resistance, I am a naive person, I've never had antiviral drugs, but I'm taking antiviral drugs, they're doing nothing to my body. So, this is something to be done. So, and then, so when do you do the genotypic test and the phenotypic test? How do you know you have developed resistance? See, when you have started, when you are newly infected, there are two situations where you can do the drug resistance testing. If you are newly infected, say in around 6 months or so, if you test, then you can know if you have got drug resistance testing. Drug resistance or not. Okay, that might be quite tricky. It might be difficult to do that. But now, for a person who has started antiviral therapy, then that is when you can do the drug resistance testing, because drug resistance testing has to be done only in the presence of antiviral therapy. That is when the mutations are going to fight back. See, when I am not being challenged, why should I fight back? Meaning, you're challenging your body with antiviral therapy. So why should I fight back? The mutants are quiet. So say in around 1 year, even if you've got the mutant form of the virus in your body, it will change into what is called the wild virus. Wild virus is one that can respond to the antiviral drugs. And the mutants, they go low. They're just going to hiding. They're no more to be found. And at that time, say in around 1 year or 2 years, after you have got the resistance, the transmitted resistance, you will find that the genotypic or the phenotypic test will not show you any kind of result, whether you have got the resistance. So if you're doing the resistance testing, you have to do it in around 6 to 7 months after you have been infected with the virus. Or after you have started your antiviral drugs. Because when you start your antiviral drugs, your body is being challenged now with the same antiviral drugs. So that is the time these mutations are going to emerge. So when you start your antiviral drugs, then say in around 3 to 4 months after starting your antiviral drug, your viral load must go undetected. This is the gold standard. If I am HIV positive, I start antiviral drugs, my viral load must go undetectable, which means less than 50 copies per milliliter of blood. This is the gold standard. That is how it has to occur. If it does not occur, then there are other reasons. Maybe you're not taking your drugs properly, or maybe your drugs are not being absorbed into your system. There is a method of testing that also, which is called as therapeutic drug monitoring test. So it's not being absorbed into your bloodstream properly, or you have got the drug resistance. Now this is the sad part of it. This poor guy or this poor woman is serious about taking antiviral drug, but doesn't know that it is not working. So that's the sad part of HIV and antiviral drugs. So how do we bring about these changes? Only by testing people who are starting therapy. I wouldn't suggest testing people after they are infected because they may not know when they were infected. So probably when starting antiviral therapy, you test for the viral load, wait for 6 months or say 5 months, See if the viral load has gone undetectable. Classic, that's what we want, it's good. But if it doesn't, try to evaluate the person whether he has been stopping drugs. He says, no, I haven't stopped drugs, no, I've been taking. That means the guy is he's doing a good job by taking his antiviral therapy regularly. That's fine. But you still find the viral load being high. That means he could have developed, he could have got the transmitted form of the virus. So if we can be testing people for drug resistance after they have initiated therapy, that would be the best we can do for people to have a full and complete life. Not just testing for resistance. Testing alone will not matter. You need to change the drugs according to his requirement, according to the mutations. You see, non-nucleoside have got several mutations, nucleoside have got few mutations, protease inhibitors have got also some mutations. So depending on the kind of mutation, you can change the antiviral drug, and we give him the best treatment, and again keep checking his viral load, and he's going to be fine. And there are several classic cases beyond any shadow of doubt. People who have been resistant to drugs, after changing drugs, boom, the viral load goes down. And then, this is what I was talking to you before. What is called as cross-resistance. If you develop resistance to one drug, like for example in the non-nucleoside reverse transcriptase, you can develop resistance to the entire class of drugs. So if you're taking non-nucleoside reverse transcriptase like efavirenz or nevirapine, you need to be very cautious. Never skip doses. But in some class of drugs like protease inhibitor, maybe skipping a dose or two may not make a big difference. But in this it does. Now this is drug-to-drug resistance. This again is very bad. How does this occur? I've already explained this before. I'm just repeating again because we are in this kind of a situation, context. This is what happens with these people who are selling other kind of medicines and claiming this will heal you, that will do this and that. It is to do with them. What happens? Your antiviral drugs needs to be metabolized in your liver. So what happens is, there is an enzyme I've already told you which is called a CYP450 enzyme, which is responsible for metabolism. I've already told you, I'm just repeating the same thing again. I am the antiviral drug. Behind me is this, the other medicine whoever gave you and told you, say, take this along with this and you'll be fine. So he's behind me. He's pushing me. Now I'm already metabolized. My drug levels are quickly going down. Now this guy comes into the picture now. So what happens is, both ways, or he's in front or I am behind him. Both ways you find two things. Either high drug toxicity or low drug concentration. I'm talking in terms of antiviral drugs. So both ways you will suffer. So that is why when you take antiviral drugs, you need to be very cautious. You see, our aim is to help people and to give them the right kind of message forward. But there are these people also amongst us and within us who also try to, I'm talking globally, even in India, who bring in these products to push, you buy this and take it with, it's a booster. The very concept is wrong. We need to change this kind of thinking, and also taking alcohol also interacts with antiviral drugs, because alcohol also plays a major role in viral replication. We will see that towards the end there's a topic on alcohol. Okay. This is a bit difficult to explain, but unless we concentrate on this, it will be easy. When I am newly infected with the virus, the type of virus that I've got is called as a wild virus. Okay? The kind of virus we call it as wild virus. What is this wild virus? Wild virus are those that respond excellently, respond very well to antiviral drugs. Meaning, I start antiviral drugs, the viral load goes down. So what happens? Along with the wild virus, there are some few mutated form of the virus which will also be there, because HIV is a mutating virus, which will also be there. So I start my antiviral drugs. Excellent. My wild virus level has gone down, my mutations are low. Excellent, this is what we want, and we are going on. Now, I stop my antiviral therapy. What happens now is, the wild virus level will again go up. Okay, I'm not really worried, because when you start again, the wild virus will go down, it's okay. But now, the key point is, the mutated form of the virus has learnt the art of survival in the presence of drugs before. because I was taking antivirals before, and there was some small bit of mutations, so it had learned the art of survival. That is the theory of evolution. That is how the virus evolves itself. It has already tasted, it has seen the drug. Now, after 1 week or 1 month, I start my antiviral therapy. The same drugs. What will happen is, wild virus level will go down. Good, that's fine. But now these mutants, these mutated form of the virus, would have already become more robust. Now they are resisting. They know who the antiviral drug is. They know who it is. Now they are resisting. And now the sad part of thing is yet to come. The mutated form of the virus will eventually, at some stage, become the dominant form of the virus. Nothing is going to work. It's just like you can just keep your antivirals in the box and lock it up. It's not going to do much. Not literally, they will do something, but that is not what we want to achieve. So this is the sad part. When you skip doses, when you stop antiviral therapy. And the more sad part of it is when you also pass it on to somebody else. Whatever resistance you have got, your antiviral which doesn't work for you also goes on to the next partner. So here, this is what I was telling you before. Can you see the wild virus? The wild virus. And then after discontinuing therapy, these mutant starts to emerge. You can see? These mutants also, they start to emerge. And then finally the mutated form of the virus becomes the dominant form of the virus. There's nothing to help you out in that. Unless you do the resistance testing. When you do the resistance testing, you'll know what are the mutations, then we change your antiviral therapy. Now coming to this transmitted resistance, this is what I was telling you. This is the mutations, okay, the transmitted resistance. That kind of virus is there. So within 6 months or 7 months, you need to do the genotypic and phenotypic test after you have initially acquired. Okay, but this might be a bit difficult as well because you never know when you got the virus. You need to. But then slowly it will become the wild virus. But wild virus doesn't mean the mutations are not there. They are there. They are there. But then when you start your antiviral therapy, that is when they will show their true color. They will be as a wild virus like this, but then there are also some mutants. So when you start your therapy, these mutated form of the virus will now show up. They will pose a threat to the drugs, the antivirals will not work. So basically what we are trying to see here is the acquired resistance and the transmitted resistance. So we have seen two types of resistance that can occur. So, as I have already told you, mutants are always there. There's no choice. And this is the wild form of the virus, the black dots that you see. This is the drug sensitive. Remember I told you, the wild virus, they respond excellently to the drugs. The drug resistant is here. This is what I told you even before I started talking about drug resistance. There is no choice. When you choose to start taking antiviral drugs, you will inevitably, beyond any shadow of doubt, you will develop, can you see the mutants? The ones which are not having the color there. So it will eventually emerge, there's no choice. So that is why people who have been taking antiviral drugs for 5 years, 6 years, 10 years, we can't set time frames, could have already developed resistance. But so that's the sad part of thing. So that is why we need to find ways how we can improve the quality of life of people. So now this is someone who is taking the drugs excellently, who is doing very well. You see this is the danger zone on top, risk of side effects and the risk of resistance. This is perfect. This is what we even saw here in the previous lecture. In this the same thing. This is the perfect, what you are seeing there. And then we see this one, I skipped a dose, you can see missing doses, resistance, they evolve. And this is evolving of resistance over a period of time. You can see this guy has skipped, here you can see this is the skipping mark. You can see now the mutants have started to evolve. Again, another skip is a disaster. All these pink dots that you see here, all mutated form of, so you can see not taking medicines. And you can see the pink dot there, drug resistant virus. So this tells you very clearly how taking your antiviral drugs is of paramount importance. So this is when there is no antiviral drugs. There is no drug pressure. I told you in the very beginning, what did I say? The moment you start taking antiviral drugs, there's a big battle taking place. These mutants, they're trying to fight back. But when you're not taking antiviral drugs, the mutants are just dosing. They're not worried because they're not under pressure to do anything. They're not. See, only when you push me, I'm going to push you back. But if you don't push me, I just remain. It's fine, isn't it? So that is what, there is no pressure now. So, but now, when you start taking antiviral drugs, this is what we call as selective drug pressure. And then mutants will eventually evolve. And this is what I've been always telling several times. This is Charles Darwin, the theory of evolution. There's a little story, I'll just go through it very quickly. I'm not very clear even if that story is very correct. What it is this was in, Charles Darwin did some kind of an study in some island somewhere. So those birds, they had some long beaks. Oh sorry, those birds did not have these long beaks. And they were not able to feed in that island. So he took some birds and put it there, and the insects were only in the holes, in the burrows, in the trees and like that. So this bird couldn't put its beak. It didn't have long beak. Over a period of time, it evolved itself to start to have long beaks. So you see how nature is. We change to situation. Like for example, okay, this is another example, but it's true. I've never tried Shima before. But then, according to the situation, if I'm given Shima, I have to eat. So situations do change. So this is how you evolve. You change, you adapt to the situation. So this is what even the mutants do. They try to adapt to the virus, and they don't, and they replicate in the presence of virus. And here's you can see some images going on there. Can you just see? It's nice. It's just is it working? You can see, yeah, it's going up here like that. So what happens, this guy is taking his drugs properly, he's perfect, no mutants, everything is perfect and fine. This guy is stopping, he's developing some resistant mutants. And now what happens is, the same guy, now again he's taking drugs, but it doesn't hold good, these resistant mutants will continue to replicate here. It's still going on. So that is the problem when you stop antiviral drugs. It's a nice cartoon, it's a nice image here, you can see. He stopped antiviral drugs, so the mutants have evolved. The same guy has again started antiviral drugs, but you find that the mutants still continue to remain. This guy is perfect, and he has started taking his drugs. The mutants are there, but they don't pose a challenge. That's why you don't see any image over there. So it only emphasizes the fact, the few things that we have learned from here. One is viral load testing, one is doing the genotypic or the phenotypic test to see if you have got resistant mutants. The other issue is adherence. So it's a lot of complex situations that are involved here. And what is this resistance testing? So I've just put a picture here to give you the distinction between genotype and a phenotype. Genotype is something what happens, you can see here X and Y chromosome. Males, we have X and Y chromosome, and here there's an X and Y. So what we see is X is dominant, and you see the phenotype. So genotype, you can't see it. You see, I was born because of my mom's gene and my dad's gene, but did I ever see the gene myself? No. But I'm seeing myself, so I know from my image that I look like my mom and dad. So that's what it means. So you can see here, the X chromosome is the dominant. You can see, again here, this X chromosome is dominant. So you can see accordingly, this color is black and this is yellow. And so we get that kind of dominance. That is a phenotype. So what is it? So the same thing over here as well. So here we see one of these chromosomes are missing and the other one is missing, inactive, X and Y, you get both X and Y. So the point I want to emphasize here is to just tell you briefly what is a genotype and a phenotype. Genotypic test looks for the strain of, looks directly onto the virus to see the genetic makeup. And as a result, you can see what are the kind of mutants that are there genetically. So what happens is, we directly look for the virus in the genotype and see what is the genetic makeup, what is the genetic sequencing, and accordingly what are the antivirals that are causing the mutations, and accordingly we change the drug. Phenotype, you do it on a test tube. You put, for example, the serum and your antiviral drugs to see which drugs are going to respond better for you, which drugs can work better for you, or can we increase this dose, the concentration, or we reduce this dose, or we change the antiviral drug. So both of these tests can help you to choose what kind of drug that you need to take. So that is the genotypic and phenotypic. And this is what, this is from my place where I come from. This is a world-class center for HIV and AIDS, exclusively for people living with AIDS. They do the genotypic, they do the phenotypic, they do the viral load, they do the CD4, they do the CD8 count. You are all out of the CD4. There is also a count to know whether how your cytotoxic T cell is doing. So there is also CD4 to CD8 ratio. There is also a CD4 percentage. See, we always go for the CD4 count, which is not 100% accurate, because CD4 can change. In the morning it's different, in the afternoon it's different, and CD4 constantly fluctuates. There is what is called as a CD4 percentage. So, for those who are interested to know, I'm sure even in the report they'll give you the CD4 percentage. So, CD4 percentage of 40 is good, meaning your immune system is doing well. A CD4 percentage of 50 is heading towards AIDS-related illnesses. So, CD4 percentage doesn't fluctuate, it doesn't change. So, CD4 count is the absolute count, number of CD4 cells per microliter of blood. CD4 percentage, number of CD4 cells in the total white blood cells. So we're just looking in the context of white blood cells. CD4 percentage is the number of CD4 cells in the total white blood cells, and that doesn't fluctuate. Anyway, this is the place where it's done. It is in my place somewhere here in Chennai somewhere. Is it there? Oh, in India, it's here. So it's somewhere there. So what we are saying is, these are centers where these resistance testing is done. You see, you can see drug resistance laboratories. So, if we can try and lobby for a resistance testing methodology right here in Zambia, it's going to change millions of lives. It's going to make a huge impact. So, why I put this slide is just to show that what I'm saying is not something from out of the window. Why I put this is I just wanted to show there are several resistance testing locations around the world. You can see around the world there are several resistance testing. So you should try and see. And if you can read this, this is quite disturbing. This is one of the studies that was done in the US. 30% of the participants who were not receiving antiviral therapy had evidence of resistance. 22% for NRTIs and 11% for non-nucleoside reverse transcriptase. So now, I don't need to talk much about this. People who have never been on antiviral therapy, they are called naive patients, and see the statistics. 30% of them were resistance, are having resistance. So I'm sure you can figure out the mathematics and statistics, what I'm trying to say for yourself. And because we are talking of human life, it should not go in vain just because of, not having to make this resistance testing available for us. And so, if you see this, this is just a cartoon which is showing non-nucleoside reverse transcriptase. It's blocking. What non-nucleoside reverse transcriptase does, it blocks the enzyme itself. It blocks the reverse transcriptase enzyme. And then what we see, as a result, this continuation of process doesn't occur. Reverse transcription doesn't occur. But here we see non-nucleoside reverse transcriptase is not working for you. And it is just, it's not working, and this, the viral replication continues. So,
up to 5 wrong nucleotides may be integrated per genome copied. Reverse transcriptase has no proofreading activity, a mechanism by which mispaired or inappropriately incorporated nucleotides can be exchanged. These errors therefore lead to a change in the viral genotype. Statistically, every possible single mutation in the HIV genome occurs many times per day. Mutations in the sequence that codes for the viral enzymes result in the production of enzymes that are subtly different from their wild-type counterparts. The activities of the wild-type enzymes are normally blocked by antiretroviral drugs. However, some mutations, called primary mutations, induce changes in the amino acid sequence, which lead to drug resistance. The location and the pattern of the mutations determine the grade of the arising resistance. For example, the mutation D30N in protease may antiretrovirals, resistance is